Hi, so I have here the two component tester that I suspect are the same from the inside, and I want to compare between them and see if I see any difference other than different, let's say, reading because of calibration or something like this. I want to see if the electronics, I suspect it's all the same, basically. So let's start with something simple. I have here a capacitor of 3300 microfarad. Let's put it on the TC1 and test it. Hope you can see it. Okay, detected as a capacitor with an ESR of 0.01 ohm, V-loss of 1.2%. I don't know what is meaning V-loss. Probably it is measuring from time to time and see what if capacitor lose voltage. And 3152 microfarad. This is close. I want to remind you that capacitors are never very accurate, so I can't really know who is mistaken with the capacitor or the instrument. Okay, this one is showing, maybe I will try to zoom because it is very hard to see the number. Okay, so 3021 microfarad V-loss, pretty much the same, let's say, between the first to the second. We'll try to measure now. I have some diode, general diode. This gives me something about the calibration, which I don't know what it is, what it means. Not calibrated, I don't know. Okay, so now we will test a diode, something silicon diode. Testing, recognize as a diode with the forward of 613 millivolts. Okay, and also the capacitance 30 picofarad. Okay, so I will put now the second one in the camera so you will be able to see it. Connecting between 1 and 3 here, and diode pretty much the same. Oh, this is already measuring not just the capacitance but also inverse current, which the first did not measure. This is nice. By the way, it's probably just a software that is doing all the other features. You don't need any extra components. Okay, this is a 100 picofarad, which is showing here 60 picofarad capacitor. Let's try it on the second one. Test. Need to press the test. This is showing damage part. Oh no, this is not. Probably it is not sitting well on the conduction. Okay, this is a 90 picofarad, which is more close to the number. Look like it is more accurate in capacitor. Now I will put some coil something. I'm not sure what coil is it, but I know it is a coil. I suspect it is maybe 470 microhenry. 400. Oh no, maybe 47 microhenry. Let's see what it measures. I'm not sure about the numbers here. I'm not sure what coil it is. Okay, and it is something 0.0 0.05 millihenry, which is 50 microhenry, and also measuring the serial resistance of the coil. Okay, nice. This is really nice instrument. One time one Chinese, or I don't know who, okay, pretty much the same. Again, we can see the measuring with components that are by the limit of the instrument, are not pretty accurate. I have here some transistor. I'm not sure what it is. I think it is something PNP bipolar, if I remember correct. Let's see. Yes, this is a PNP bipolar HFE 40 VBE. By the way, you can see that it is closing after 10 seconds. I will try to update it. Can change it till 25 I think seconds by opening the box, and we'll see it soon. Okay, pretty much the same. These component testers are pretty well, working pretty well. I will try to put now, I think this is some Mosfet. I'm not sure which, but I know it is a Mosfet. You can look at the data sheet, and it is okay. We can see a V threshold 2.9 volt. We can see a RDS, which means the resistance between drain to source, 1.4 ohm. Voltage forward, we can see that we have a diode protection, and it is writing what is gate, source and drain. Pretty nice. Actually nice. Instead of searching for datasheet, just pressing the button and getting all the data. And you can see that it is much the same. So I don't see any difference between these two testers. Let's try to put, I have here a Rgb Led. Let's see if it will find out what it is. I can connect just 3 pins out of 4, so it did detect 2 diodes. You can see that the voltage forward is different because one of them is each color is different, and the blue usually is near 3 volts, and the red and the green are lower voltage. This is quite impressive that this tester can also give me all this data out. The second one, let's see. Yes, it's pretty the same, 2 diodes. I'm pretty impressed. Now I will give it something that should be a little harder, because I have here a Zener Diode. Let's search for the data of the Zener Diode, and it did not detect that this is a Zener Diode, just a diode. Let's try the inverse. The reason I'm doing it, because the TC1 has, okay, so this cannot detect Zener Diode. This can. I have here anode and cathode, so I will try to put it in the diode, in the cathode and the anode, and to check. Okay, we can see that this is a Zener with 5.0 46 volts. So this one is better because it can detect Zener diode, which I don't see with the other tester. Let's give it a second chance. Maybe the down contact will be able to detect it, and they can't. The reason is that in order to check a Zener diode, of course, you must have a DC to DC converter in order to up the voltage from the 3 volts or 9 volts to the Zener voltage. So pretty much good results. And the second video will be how to update the time of the TC1 from 10 seconds to 25. We found something and we will try it. Okay, so let's disassemble TS1, trying to find how to update the time, the standby time, till it is turning off the LCD. Let's try to do it. So gently I'm disassembling 4 screws. Now this is just a plastic and another plastic, and we have a battery with a connector. Disconnect the battery. Yes, and I have here 2 pins. I will try to zoom to show you the data. It's a little tricky to get it to the cam. Okay, so if you can see, we need 1 and 1 with these 2 pins in order to get no, we need 0 and 0 to get 25 seconds. So 0 and 0. This is strange. This means that these 2 pins now get 1 and 1. I'm not sure about it. So now let's check. Let's check what we get. I will try to zoom it. I've never done this before, so I will now try to find out if this really gets, what is the voltage that I get in these 2 pins. So I have here probably ground. Yes, there is a 1 and a 1, so I need to connect them to ground. So I need to assume that I have here some pull-up resistor. Let's see if I can find a pull-up resistor. It's a little hard to go over the traces, but because this is below this switch and going I don't know where, so let's just try to see which are the resistors, if any of them. Okay, I will just connect it to ground and that's all. By the way, this is probably the coil that is doing voltage change from 4 volt for the Zener diode for testing. So I will now connect these two pins to ground. So I will show you how to do it, let's say in the most effective way. So let's see by the connector, this is the ground, yes, and probably this is also the ground. So what you can do, I assume that if I'm scratching here, so this is a ground, yes. So what you can do is basically what I'm doing right now, just moving the silk from the PCB, and since all need to be connected to ground, so I will solder them all together. Hopefully it will be okay. Guess it will be okay. Try to zoom here a little. So let's try and do the 25 seconds change. So my soldering is now getting hot and need to find soldering. Okay, so I have here a solder test. So this is pretty simple, just put in here solder paste, and also here, and also here, and connecting all together. This is a little tricky. I think now it is fine, and hopefully it will not burn out when I'm connecting back the power. And it is working. And let's see if the time was updated. I will put just a resistor. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's a little less than 25 seconds, I have to admit. Expect it to be more time, and by the connection I'm sure that everything here is grounded. Let's check the voltage. Yes. So I'm not sure if the time, there is a time. Is these two connection again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, it's not 25 seconds. For sure this is not 25 seconds. So I will do some reverse engineering in order to know how to change the time. Okay, thank you for now.